Welcome to my channel. Today's lesson is factorization. And when we talk about factorization initiated from the word factor, and another term for the word factor is a divisor. So simple mathematics, if 8 can be expressed as 2 times 4, because we all know that 2 times 4 is 8, we can simply say that 8 is divisible by 2 to get a 4, and 8 is divisible by 4 to get a 2. So alternatively, we can call 2 a divisor of 8, which means 8 is divisible by 2, so 2 is a divisor of 8, and 4 is a divisor of 8, or we can say it is a factor of 8. So factor and divisor are the same. Now, one reason why we express a number as a product of its factors is to be able to simplify. So for example, 8 divided by 2. I know that 8 divided by 2 is a 4. This is simple mathematics, but just to show the concept, if I express 8 as a product of its factors, 2 times 4 on 2, then can we simplify 2 by 2? 2 divided by 2 is a 1, and 1 times 4 is equal to 4. Is 8 divided by 2 is equal to 4? Yes, so we can actually simplify 2 by 2. Why? Because 2 is multiplied by 4. Now, if we do the same, but instead of expressing 8 as a product of its factors, we're going to express it as a sum of two numbers. Let's say 2 plus 6, and 2 plus 6 is 8. And then I'm going to go on to, will I get the 4 if I simplify this by that? 2 divided by 2 is a 1. 1 plus 6 is a 7, which is not the answer I'm expecting, so I cannot actually simplify 2 by 2. And the difference between these two, the 2 here is added to another term, but 2 here is multiplied by another term. So it's very important when express a number in terms of simplifying a mathematical expression. So express a number as a product of its factors rather than expressing the number as a sum or a difference of two numbers. Now, how to apply this in algebra? So, for example, example 1, question is to simplify 2x minus 6 on 2. Now, I can simplify 2 by 2. But remember that 2 is part of that 2x, and the 2x and 6 are subtracted. So we learned from the previous example that if the terms are added or subtracted, we cannot simplify. So my aim now is to, instead of having 2x minus 6, can I change that into a product of factors? One of the methods we're going to learn afterwards is taking the highest common factor, and simply the highest common factor, the two terms are divisible by 2. So the highest common factor is a 2, and I have x minus 3 left inside. Divide by 2. Now the 2 is multiplied. Yes, now I can simplify, and simply I'll get x minus 3. So the first reason why we factorize, or converting added or subtracted terms into a product of factors, is to be able to simplify. One more example, example 2. If I have x squared minus 3x divided by x, I can simply go x squared minus 3x on x. Again, I cannot simplify x with any of the x's up there because the two terms are subtracted. But if I factorize by taking the x as a common factor, as the two terms are divisible by x, leaving x minus 3 on x. Now this mathematical term in the numerator of the fraction is changed into x multiplied by x minus 3, which means this mathematical term can be divided by x and can be divided by the bracket x minus 3. So x divided by x is a 1, and I'm gonna get x minus 3. So now the first benefit of factorizing is to simplify. Now, another reason why we factorize is what we call the null factor property, and actually null is a 0. And the product, when I have a product of two numbers or even three numbers and the numbers are different and this product is equal to 0, I can simply conclude that any of these numbers must be a 0 to get a product of 0. So either a is equal to 0, or b is equal to 0, or c is equal to 0. In algebra, we might find a question like solve example 1, and the question is to solve a higher degree equation like x squared minus 2x is equal to 0. In order to use this property, I need to express that mathematical expression as a product of its factors, and the only way to do that is using my factorization methods, and we have 6 factorization methods. We're gonna go through them in details in our next lessons, but taking the highest common factor here, which is my first method of factorization, both terms are divisible by x, so I can change that into a product of two factors. X squared when divided by x, I get the x, minus 2x when divided by x, I get the minus 2 equal to 0. Now, can we use that property? Two terms or two factors when multiplied, I get a 0. I can then simply conclude that either x equal to 0, and this is one solution, or x minus 2 must be equal to 0, and for this to happen, x must be equal to 2. Let's confirm. Let's put that x back there. X squared, when x is a 0, 0 squared is a 0, minus 2 times 0 is a 0. Is 0 minus 0 a 0? Yes, so this solution is right. Now, what's about the x equal to 2? If I put 2 squared is a 4, yes, minus 2 times 2 is a 4. Is 4 minus 4 a 0? Yes, so this solution is right too. So now we learned that factorization is expressing a mathematical term, mathematical expression which is consisting of added and subtracted terms into a product of two or more factors. What else we learned today is why do we factorize? So not only factorize it, what is the process of factorization, but why. And this is the main thing. You need to know why and when you're gonna apply that. Why is to be able, number one, to simplify. Number two is to use the null factor property. Next lesson, we'll take the first two methods of factorization. In total, we have 6 methods of factorization. Number one is highest common factor. Number two is the difference of two squares. Then we have one lesson on these two methods, and then we have 4 more methods to learn. Once you're on top of your 6 methods of factorization, you're not to worry anymore about factorization. Thank you so much. I'll see you next time.